there any questions you don't want to ask?
Can I ask a question?
Go ahead.
Can you explain the difference between procedural automation and state-based control? Or are they the same thing? Or if not, what are the differences between the two?
That's a good question. Basically, a state-based control is implementation of procedural automation. Procedural automation, as the ISA 106, is basically covers more than just the engines that runs the process. Therefore, state-based control is one of the definitions of ISA 106, how to implement it.
Thank you.
We can ask Dave Emerson, did I answer right? Very good.
Oh, we have a question back here.
Question for Mr. Pedersen. In one of your slides, you showed a link between Plant PAX and your maintenance system. Is that an inherent link that is something that you got out of Plant PAX, or did you guys write something that pulled that data up?
No, that the vendor did that. That wasn't anything custom. The vendor took it on, and if they wrote some code on their side of the fence, I would call it an adapter. That's how they pull it into their own system and then publish it out of their own system in standard format. So every supplier can do the same thing, and the advantage of that approach is that the owner-operator now doesn't have to maintain all those APIs. Those APIs are very expensive to build in the first place. They're very expensive to maintain and upgrade. And you wind up with as many applications that have to talk to each other are n, you wind up with 2 to the n minus 1 interfaces. With this other approach, each supplier and each application just writes one adapter that talks to standard, and then any other application that writes their own adapter that talks to standard can exchange data with it. And that's very beneficial because now the onus of maintaining and upgrading that software is on the supplier side of the fence. One of my past experiences was I used to have to take down my whole refinery system when Oracle came out with an upgrade because some of those applications were running off an Oracle database. So wound up over a weekend taking everything down, upgrading Oracle, changing the interfaces of other software that use that Oracle data, and then bringing everything back up. And by the way, I had to have it online by 8 o'clock on Monday morning when the shift, or after the shift changed and management and engineering came in. And it was a very stressful time in a few cases because nothing ever goes right the first time when you're dealing with computers. And second time, Nazer said.
For the example you presented about distillation column, what is the business proposition to do procedural automation for a distillation column? Is the business value only on the startup and shutdown, or there is more value?
No, basically a startup, we do it every 8 years or so. Therefore, for our continuous processes, that doesn't add value, adds value because the next operator is not there. The main advantage
I didn't hear the business value is one operator versus the operator, how to operate a steady state distillation column, or I mean, in
remember
a regular operation require this kind of
yes.
application?
Yes, because basically the business value we have is our sites are well integrated. Therefore, any hiccup in any of our plant affect everybody else. Therefore, all of our sites, the operators is running at the unit level, yes, and that's a business proposal, not at the loop level. The number of operators we have compared to industry is very limited, very minimum, and they know how to run their plants because they rely on the computer system much more. Our operators are well trained to read all of our logics. They can understand the logics. They can detect what's wrong, how to improve it. Therefore, the business value for us is to have the operator discipline embedded in running plant. A startup is a one advantage, but overall, when we run the processes in all of our plants, state-based control is enable of the operator to run it much more better.
I would propose multivariable control will do a much better
We have
job.
multivariable control in majority of our plant, but multivariable control is add values of how much it goes. It doesn't interfere with the pumps or the valves. Multivariable control, optimization that I'm not talking about, we are the biggest user of multivariable control in Dow Chemical, and RT-up and other stuff.
I could just add that the business proposition kind of depends on how often you start up and shut down. You know, chemical plants and batch plants, they do it quite frequently. Oil refineries, we don't start up those units and shut them down for 2, 3, 4, 5 years running, maybe little pieces of it. So we have operating procedures that are written. The operators call them up out of the electronic document management system when they need to shut down a heater or swing a exchanger train or that kind of thing. So if you do it frequently and often, there's money to be made, definitely. If you do it very infrequently, you're probably going to put the money in something that pays back better and faster.
Just to add, one of the things that we're not talking about is operator training. And then if you only do a procedure once every 8 years, your operator doesn't have a lot of experience doing that action. And if you automate the shutdown, he doesn't need as much. He doesn't need to go through a piece of paper, which may be out of date because you did a project during those 8 years, or maybe you hired him during those 8 years and he's never shut the plant down. He's never started it back up.
Yeah,
that's another thing that the procedural automation will address.
I'll add that's a really good concept to have. In practice, not everything is automated. So the procedures usually have things that you got to do out in the field, like change a block valve, move an MOV, etc. Open a bypass, close a bypass. That's not automated. And then you can do other things that are hooked to the system that are automated. So it becomes a sequence of manual steps and automated steps and more manual steps and more automated steps. So nothing's fully automated in our plants because we never can justify spending the money to automate everything.
I spent 5 years with Exxon Chemical, therefore I know how the refinery sites work. This is a big difference between refinery and chemicals. In chemical operations, we're running very smaller units. They are changing. They need to run different products. It's not batch, but we run them differently. Therefore, putting our operating discipline in running the plant is very beneficial for us. In big refineries, that's not the case for them. And basically, the case for them is running exactly the same thing forever. But I challenge you, look at your furnace cracker operations, if you are an owner-operator, and look at how many times you need to spend, how many people you send out to these furnaces to start a furnace. And I'm talking about these furnaces that are huge. Yes, it's not just a little furnace. And how your burner management works, how your furnace operation works, how your swapping of furnaces works. In Dow, we do all of that automatically. We spend sometimes, but our cost of developing process automation is not bigger than the refinery partners that they do not operate. Therefore, the question is to you, if you're spending the same amount of money, whether you will go for fully automated, as ISA 106 says, or you go manual, that's your choice, yes? But then you spend tremendous amount of money to do alarm optimization, alarm shelving, doing A or B or C. Again, two different paths, and I have seen in a major oil refineries, they are not using this technology. Whereas in the chemical side, where it's between very big continuous and semi-batch, we use this technology a lot.
Anyone else? Want to break for coffee?
I just want to add one little thing that it probably wasn't clear in my presentation, and that is the standards work that's going on. A lot of that is, underneath that is 5 standard organizations that have, a number of years ago, decided to collaborate and merge their standards. And one of them is ISA. So ISA 95 and ISA 106 and all those things are are incorporated in that initiative. It's called the Open O&M Initiative. O&M stands for Operations and Maintenance. And the 5 standards bodies are ISA on the instrument side and the measurement side, if you will, Mimosa on the machinery side, World Batch Federation, which is now part of MESA, on the batch processing side, OAGI, which is the Open Applications Group that looks after discrete products. And the 5th is, it escapes me right now. I'll think of it in a minute. But those 5 bodies collaborated and are now working together under ISO to merge this whole thing. And by the way, those standards become implementable. The schemas are defined, the XMLs are written, and it's implementable. Whereas you look at ISA 95 and ISA 88, they're more conceptual and architectural standards. You can implement it in 1,000 different ways. What we're trying to get to is one standard implementation that all suppliers can subscribe to and just write some adapter code that talks the language, and then everybody can talk to everybody else.
One quick question. Yeah, is that LinkedIn group on state-based control and procedural automation, is that active now?
Yes, I just.
Okay.
Yes, the procedural automation is active.
Thank you.
Okay, well, if there's no more questions, thank you very much for coming.